This is Eapcet 23 question. Here is given the line 2x plus root 6y is equal to 2. Touches the hyperbola x square minus 2y square is equal to 4. Then the coordinates of the hyperbola is. Now we find the touching point for this hyperbola. Here is given line is, that is 2x plus root 6 into y is equal to 2. From this, root 6y is equal to minus 2x plus 2. So y is equal to, this is minus 2x by root 6 plus 2 by root 6. This is the line in the form y is equal to mx plus c. And the given hyperbola is, that is x square minus 2y square is equal to 4. Standard form x square by 4 minus y square by 2 is equal to 1. Total equation. So touching point, that is point of contact, is equal to point of contact is equal to minus a square m by c comma b square by c. This is the formula, minus b square by c. So substituting all the values in this equation, that is minus a square, this is minus 4 into m, slope is minus 2 by root 6 by c, 2 by root. C value is 2 by root 6, comma minus b square is 2 by c value, this is 2 by root 6, 2 by root 6 cancelled, that is equal to minus root 6. This point of contact. Here minus into minus plus 4. This is 4 comma minus root 6. This is the required answer. The second question. Here is given, if the angle between the asymptotes of a hyperbola is 30 degrees, then the eccentricity of the hyperbola is. So we know that the formula for eccentricity, that is theta is equal to 2 sec inverse e. This is the formula for finding the eccentricity of the hyperbola. Here theta is given, that theta is equal to 30 degrees. Substituting in this is 30 degrees is equal to 2 sec inverse of e. From this, sec inverse of e is equal to 30 by 2 is 15 degrees. So eccentricity e is equal to sec 15. Sec 15 degrees is equal to, that is, this is the formula, that is root 6 minus root 2. This is the answer. This is third question from hyperbola, Eapcet 2023. Here is given, if the equation x plus y plus n is equal to 0 represents a normal to the hyperbola x square by 6 minus y square by 2 is equal to 1, then n is equal to dash. We know that the formula for, that is lx plus my plus n is equal to 0 is a normal to the hyperbola x square by a square minus y square by b square is equal to 1 is, that is a square by l square minus b square by m square is equal to square plus b square whole square by n. This is the condition for the normality. Substituting the values in this equation, a square, here a value is given 6, that is 6 by l square, l value is x coefficient is 1 square is 1, minus b square 2 by m square is 1, that is equal to a square plus b square, that is 6 plus 2 whole square by n square, n value is n. So from this 6 minus 2, 4 is equal to 6 plus 2, 8 square 64. This is 64 by n square. From this, n square is equal to 64 by 4. Therefore 1 times 60 times cancel. From this, n square is equal to 16. N is, that is equal to plus or minus 4. This is the value of n. This is fourth question from the hyperbola. TSM set 23 question. Here is given y is equal to mx plus 4, where m greater than 0 is a tangent to the hyperbola x square by 25 minus y square by 9 is equal to 1. Then the point of contact of the tangent is dash. So here is given line is y is equal to mx plus 4 is a tangent to the hyperbola. So condition for tangents is c square is equal to a square m square minus b square. Here c value is, that is 4, that is c square is equal to 16, a square that is 25, m square is m square minus b square is 9. This is 16 plus 9 is equal to 25 m square. From this 25 is equal to 25 m square. 25 cancel, that is m square is equal to 1. Take m is equal to 1. Here is given m is greater than 0. Take the value of m is 1. Therefore, the line equation is y is equal to mx plus 4. Substituting m value, y is equal to x plus 4. This is the line tangent to the given hyperbola. Now find the point of contact. So point of contact is equal to, so point of contact is equal to, this is minus a square m by c comma minus b square by c. This is the formula. So minus a square is 25, m value is 1 by c is 4, that is minus b square. This is minus b square is 9 by c is 4, that is equal to, this is minus 25 by 4 comma minus 9 by 4. This is the point of contact to the hyperbola. This is fifth question from hyperbola, Eapcet 23 TS. Here is given the equation of the hyperbola is 9x square minus 16y square plus 72x minus 32y minus 16 is equal to 0. Then the equation of conjugate hyperbola is dash. Given hyperbola is, that is 9x square plus 72x minus 16y square minus 32y is equal to 16. This is the equation of the hyperbola. Now take 9 common. This is 9 into x square plus, this is 8x minus 16, take common. This is y square plus 2y is equal to 16. This is 9 into x square plus 8x is written as, this is 2 into x into 4. This is in the form of a square plus 2ab. Here b value is 4, that is b square is 16. So here is adding 9 into 16 minus 16 into, this is y square plus 2 into y into 1. Here b value is 1, b square is 1, that is equal to, this is 16. Here is adding 9 into 16, that is 144. And minus 16 into 1, this is minus 16. Both sides 16, 16 cancel. This is 9 into x plus 4 whole square minus 16 into y plus 1 whole square is equal to 144. This is the hyperbola equation. Now find the conjugate for this conjugate hyperbola. Conjugate hyperbola is equal to, just differ by minus 1, that is 9 into x plus 4 whole square minus 16 into y plus 1 whole square is equal to, this is minus 144. This is the conjugate hyperbola for the given hyperbola. So now releasing this, 9 into x plus 4 whole square, x square plus 8x plus 16 minus 16 into, this is y square plus 2y plus 1 is equal to minus 144. Multiplying by 9, this is 9x square plus 8 9 is 72x plus 144 minus 16y square minus 32y minus 16 is equal to minus 144. Therefore, equation of the conjugate hyperbola is, this is 9x square minus 16y square minus 72x This is plus 72x minus 32y. Here 144 plus 144, that is 288 minus 16, that is 2. This is 272. So plus 272 is equal to 0. This is the equation of conjugate hyperbola. This is sixth question from Hyperbola, Eapcet 23 TS. Here is given P a secant theta comma B tan theta, and Q is given a sec phi comma B tan pi are 2 points on the hyperbola x square by a square plus y square by b square is equal to 1, where theta plus pi is equal to pi by 2. If h comma k is the point of intersection of the normals drawn at P and Q, then the value of k is dash. This is the question. Here is given. So two normals is given at P and Q. Normal equation at P. Normal equation at P is equal to, that is ax by secant theta plus by by tan theta is equal to a square plus b square. This is the equation of the normal at P. And normal equation at Q. Normal equation at Q. Normal equation is, that is ax by sec phi plus by by tan pi is equal to a square plus b square. This is second equation. Here is given theta plus pi is equal to pi by 2. Substituting pi value in this equation, that is theta plus pi is equal to pi by 2. From this, pi is equal to pi by 2 minus theta. Substituting in this equation, that is ax by sec of pi by 2 minus theta plus by by tan of pi by 2 minus theta is equal to a square plus b square. From this is ax by sec of 180 sec of 90 minus theta. This is cosec theta plus by by tan 90 minus theta. This is cot theta is equal to a square plus b square. This is third equation. Solving this first equation and third equation, we are getting the value of k. So first equation multiplying by, that is first equation multiplying by, that is sin theta, that is first equation into sin theta, that is equal to, this is ax into sin theta cos theta. So 1 by secant theta is cos theta plus by tan theta into by by tan theta is, this is cot theta into multiplying by sin theta. This is sin theta is equal to a square plus b square into sin theta. And third equation multiplying by cos theta, that is equal to, this is ax into 1 by cosec theta is sin theta, this is cos theta, plus by into 1 by cot theta is tan theta into cos theta, that is equal to a square plus b square into cos theta. Subtracting these two equations, this is minus 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 minus. This value is ax sin theta cos theta is cancelled. This is by cot theta into sin theta, that is cos theta by sin theta. Here sin theta cancel, by sin theta by cos theta. This is, we take by common, this is cos theta minus sin theta is equal to, here take a square plus b square common, this is sin theta minus cos theta. So take minus common in this, this is minus by into sin theta minus cos theta is equal to, this is a square plus b square into, this is sin theta minus cos theta. So both sides sin theta minus cos theta cancel. From this y is equal to a square plus b square by minus b. So this is the value of k, where k is equal to minus of a square plus b square by b. This is the value of k. This is next question from Hyperbola. This is AP Eapcet 23 question. Here is given x plus y plus 1 is equal to 0, x minus y plus 4 is equal to 0. Be the asymptotes of a hyperbola. If 1 comma 1 is a point on the hyperbola, then the length of the hyperbola is, then the length of the lattice rectum, then the length of the lattice rectum. Then the length of the lattice rectum is dash. We know that the formula length of the lattice rectum LLR is equal to 2b square by a. This is the formula for finding the length of the lattice rectum, 2b square by a. That is, here is given two asymptotes is given. Now equation of the hyperbola is hyperbola and its asymptotes are differ by a constant. So equation of the hyperbola is, this is x plus y plus 1 into x minus y plus 4 plus k is equal to 0. This is the equation of the hyperbola. This hyperbola passes through the point 1 comma 1. Substituting 1 comma 1 in this equation, 1 plus 1 plus 1. This is 3 into 1 minus 1 plus 4. This is 4 into plus k is equal to 0. From this k is equal to minus 12. This is the value of k. Substituting k value in the hyperbola equation, that is x plus y plus 1 into, this is x minus y plus 4 minus 12 is equal to 0. Multiplying these two, x plus y into x minus y. This is x square minus y square. X plus y into 4. This is 4x plus 4y. X minus y into 1. This is x minus y plus 4 minus 12 is equal to 0. This is, and x into, this is the equation of the hyperbola, that is x square minus y square. This is x square minus y square, 4x plus x. This is 5x, 4y minus y. This is plus 3y. 4 minus 12 minus 8 is equal to 0. This is the equation of the hyperbola. Now we find the length of the lattice rectum. Now convert into standard form. This is x square plus 5x, x terms, and y terms is, take minus common. This is y square minus 3y is equal to 8. Now this is converting into a plus b whole square, that is x square plus 5x, adding this is 25 by 4, b square term, minus y square, this is minus 3y plus 9 by 4, here is 3 by 2, squaring on that, 9 by 4 is equal to 8 plus 25 by 4 minus 9 by 4. This is x plus 5 by 2 whole square minus, this is y minus 3 by 2 whole square is equal to 8 plus 25 minus 9, 16 by 4 is 16 by 4, that is equal to 4. 8 plus 4 is equal to 2. Now dividing the total equation by 12, therefore hyperbola equation is x plus 5 by 2 whole square by 12 minus, this is y minus 3 by 2 whole square by 12, this is equal to 1. So this is the equation of the hyperbola. Now length of the lattice rectum 2b square by a. Here a square is equal to 12, b square is equal to 12. Substituting, therefore length of the lattice rectum is equal to 2b square by a. Here 2 into b square is 12 and a is root 12. So that is equal to 2 into 12, 24 by root 12 is 4 into 3, that is 2 root 3. Here 2, this is 12 times cancel, that is 12 is written as 4 into 3 by root 3. This root 3, here root 3 times cancel, that is equal to 4 root 3. This is the length of the latus rectum. This is next question from Eapcet 23. Here is given the equation of the pair of asymptotes of the hyperbola x minus 3 whole square by 3 plus minus y minus 2 whole square by 2 is equal to 1. Asymptotes and its hyperbola are differ by a constant. Here is one is given, that is asymptotes equation is, pair of asymptotes equation is x minus 3 whole square by 3 minus y minus 2 whole square by 2 is equal to, here is 1 is given, asymptotes equation is 0. So now take LCM, this is 2 into x minus 3 whole square, x square minus 6x plus 9 minus 3 into y minus 2 whole square, y square minus 4y plus 4 is equal to 0. So multiplying this is 2x square minus this is 12x plus 18 minus 3y square plus 12y minus 12 is equal to 0. From this is 2x square minus 3y square. This is minus 12x plus 12y. 18 minus 12 plus 6 is equal to 0. This is the equation of pair of asymptotes to the given hyperbola. This is ninth question from Eapcet. This is Eapcet 23. Here is given, let small e be the eccentricity of the ellipse x square by 4 plus y square by 9 is equal to 1. And 1 by e is the eccentricity of the hyperbola. Then the eccentricity of the conjugate hyperbola is, we know that the formula for hyperbola, that is 1 by e1 square plus 1 by e2 square is equal to 1. This is the relation between the eccentricities of a hyperbola and its conjugate hyperbola. Here is given e be the eccentricity of the ellipse. We know that the formula for ellipse eccentricity e is equal to square root of, this is b square minus a square by b square. This is the second type of the ellipse. This is b square is 9 minus 4 by 9. 9 minus 4 is 5. This is root 5 by root 9 is 3. This is the eccentricity of the ellipse. Now eccentricity of the hyperbola. Eccentricity hyperbola. Take this is e1 is equal to, in the problem that is given 1 by e. 1 by e is, that is 3 by root 5. Now substituting in this formula, that is 1 by e1 square plus 1 by e2 square is equal to 1. 1 by e1 square, here e1 value is 3 by root 5. 1 by e1 square, that is 5 by 9 plus 1 by e2 square is equal to 1. From this e2 square, 1 by e2 square is equal to 1 minus 5 by 9, that is equal 9 minus 5, 4 by 9. From this 1 by e2 is equal to 2 by 3. So from this a2 is equal to 3 by 2. This is the eccentricity of the conjugate hyperbola. This is Eapcet question from 23. The equation of the pair of asymptotes of the hyperbola x square minus 2y square minus 8x plus 8y plus 4 is equal to 0. This is the equation of a hyperbola. Now pair of asymptotes equation is, that is hyperbola and its asymptotes equation differ by a constant. That is asymptotes equation is x square minus 2y square minus 8x plus 8y plus k is equal to 0. This is the equation of pair of asymptotes. This equation represents a pair of line. That means pair of line represents means, we know that the formula, that is delta is equal to 0. Delta means this is ABC plus 2FGH minus AF square minus BZ square minus CH square is equal to 0. Here 2HXY term is missing, so H value is 0. This is equal to 0. This is also 0. Values, remaining values. A value is x square coefficient 1, b value y square coefficient minus 2, c value constant term k. minus a 1 into f square. F is y coefficient, that is 2f is equal to 8. From this f is equal to 4. F square is 16 minus b, this is minus 2g square, this is x coefficient, 2 minus 8, g is equal to minus 4. So g square is, this is also 16 is equal to 0. This is minus 2k, this is minus 1 into, this is 16. This is minus 16 plus 2 into 16, 32 is equal to 0. From this 2k is equal to 32 minus 16 is 16. From this k is equal to 8. The value of k is 8. Substituting the k value in asymptote's equation. Therefore, required equation is, therefore, pair of asymptote's equation, pair of asymptote's equation is x square minus 2y square minus 8x plus 8y plus k value is 8 plus 8 is equal to 0. This